So this is 4,6 beta. And here's the question we're going to deal with first. So that picture on the board, which you couldn't see on Friday, we drew. So the observer 70 meters south of the railroad crossing, and the train's going east at 60 meters per second. How fast? 20 meters per second the train moving away from the observer, 4 seconds after it passes through. So this is 60 meters per second. After 4 seconds, the train will travel 240 meters. You have the 7, 24, 25 common right triangle under a side change of magnitude 10. Make sense? So the question is, this thing is moving, the train's going, so you're going to have that yellow distance. Then you're going to have a different one. It's getting, the train is moving away from the observer that's down here in this southwest view. What are we trying to do? Well, for the purpose of consistency, in this picture, I call this X, this is Y, there's one horizontal, one vertical, and I call this R. We're calling it R because you want to call it H for hypotenuse, then we try to confuse the H with the height and the size. You call whatever length you want. Okay? So you're trying to find this DRDT. You try to find a change with that hypotenuse with respect to time. And you were given some. You were given the XDT. Now, there are two approaches to relate rate problem. This problem can be done with either approach. The question we're going to take you to from the AP test in 2016 would be done with dimensional analysis. So the two approaches are dimensional analysis or implicit differentiation. Not every problem can be done both ways. Because you might have a preference. It took me a while to get my mind around implicit differentiation, and now I'm comfortable with it, so I'm going to try and do it that way. If somebody else has I do dimensional analysis of chemistry, I'm comfortable with that. But it's like being on the basketball team. If you're on the basketball team, you gotta need the ball over half court. If you're all hand, you might prefer, I wish you could do a ball with your right hand every time. If you're on the team, your right hand, you gotta get your left hand. You're gonna have the ball the whole time. Why are we going to ball? Yeah, you might have to do one. So, in order to do this, we need to get rid of the dx, because there's no dx in our trying to find. We need to introduce the dr. Under those circumstances, the dx would reduce. Make sense? So if we can find dr dx, we can multiply by what was given. We try to find. Or, if we want to do the problem implicitly, we could say, implicitly, we would say, x squared plus y squared equals r squared. We want to take the derivative with respect to t of the whole thing. Okay? So all we do is set it up for you, and you go at the problem whichever way you feel most comfortable. Now, okay, so Here's the picture. So the first thing is, if you did it implicitly, what do we get? 2x dx dt plus 2y divided dt equals 2r dr dt. That's, we're trying to get dr dt. That's what we're looking for. So where does it 2x? We wrote 2 times what x equals, 240. Times the x dt, which was 60. They told us that was the change horizontal with respect to time. Plus 2y, 2 times 70, dy dt. It's 0. The observer is not getting closer to the train tracks. That's not changing. So that's a 0 equals 2 times r, which is 250. The r dt is what we're trying to find. So that's a 0. We have that product divided by 500. That's dr dt. Now, the dimensional analysis part, which when we take you to the College Board website, we kind of force this into dimensional analysis. Where you'll see the problem we're going to test in 2016 is much more user-friendly for this technique. So here's my table. dx dt was given, right? I want to find dr dx. To find dr dx, here's the same work we did up above. I have 2x equals 2r. The 2 is reduced. You divide both sides by 2r. You're going to get x over r equals the r dt divided by x dt. Well, the dt's are reduced, and you get the r dx. So the 2 is reduced, or you put it 2 times, doesn't matter. You put the 240 in there, or 480, 480 or 500, same thing. I was given, and you would get the answer of the multiple choice. The closest answer is 57 6/10. That's what this is going to give you. 288,000 divided by 500. Would be, I'm off by a decimal. That's the 57 6/10. Okay. I think this should be 28,800. Let me fix that. Two times 240. 60. Yeah, it's 28,800, not 288,000. All right. So I'll edit that. God bless you. This numerator should be 28,800, and that's what takes you to 57 6/10 meters per second. All right. So next thing, we are going here. The calculus page. I need you to be able to do this. I need you to go here right now. You're in the room, and that's your Chromebook, and you're at home, do this. You're going to the link in Canvas for College Board in the resources folder to the released questions. Okay, so right here, we'll take you to this page right here. Look familiar to you? That link is in Canvas. So you scroll down, what they got? The 2019 questions only are on this page. At the very bottom, it says past exam questions. You click on that. Now, how do I know what I'm looking for? Because of this. This document is in there. And we outline all the previous tasks, well, within the last 7 years. We outline those tasks and broken down by component and textbook section. So they released the information that was asked these questions, no multiple questions. But in 2019, the last time it was the whole test was administered, people got the same test. But unless you got the test that they were previewing, you got these questions. But this gives you an idea. And this asterisk up here tells you whether that was common to the AB test. So you'll see 2019, the first 2 questions using calculator. The last 4, no calculator. 1, 3, and 4 were common questions to the AB. Then 2 and 5 were different questions than AB got, and 6 is always a chapter 9 question. Okay. So you have an idea, well, okay, how much of this stuff have we covered? You look up here, you can't do anything in their entirety. If you got related rates of Bob 4, you put some differentiation and then go to chapter 6. You couldn't miss it. You scroll down here, and again, this document itself, that's the handout. The document that you're looking at is a longer document. Okay, I want to see the table to the right. I want to see my document from Canvas with that table. You can find it. Anticipated FRQ. It's at the bottom of the document. It's different. None of this information there. You have this table at the bottom of the document, right? Same thing. If you're at home, you're going to be able to find this stuff. You can't say, oh, here. You're so hard. We gave that a hard copy of this, so you don't see it very much. But there was nothing to add for the year. I scrolled down to 2016. And I'm looking at problem number 5, which, ready, is common in the AB test. That's what the asterisk is. Only point C, right? You need to get the 5 straight, you get to that part A. You need to combine, you can do part B. The part C is common, AB, that's what we're doing now. We're just going to go to that question. Does this make sense to people what we're doing? So we go back here. I scroll down till I get to 2016. First thing you have the question, the scoring guide. You can compare your work to the BC scoring guide, College Board scoring guide, and then some sample responses, and then how people build the question. But really, we're concerned with first response. So we're here. And we know we're looking for question 5. There it is. It is the infamous funnel problem. And all we're going to do is part C. You have this funnel, and the height is 10 inches, and it has circular cross section. The radius can be determined as a function of the height between 0 and 10. So C and, ready? A, find the average value of radius of the funnel. Yeah, that's chapter 5. We didn't get to that. Find the volume of the funnel. Well, people have got lumped up in this question. We're going to make it more user-friendly for you to get by that. Just to rotate the funnel on this. People got confused because they couldn't look at the axis. But if you rotated the funnel, it wasn't wanting to do that. But you had to see the rotate. C. The funnel contains liquid that is draining from the bottom. When the height is 3 inches, the radius of the surface of the liquid is decreasing at a rate of 1/5 inch per second. What is the rate of change of the height with respect to time? Yeah, right. We're going to do this problem by dimensional analysis. We build a table. They want to know this. What is the rate of change of the height? They're asking you to find the HDT. What was given? The radius is decreasing at a rate of 1/5 inch per second. They're giving you the RDT. What would you multiply that by to get what you're looking for? Is that right there? Begin.